Question 1 for 4 marks. Part A. Simplify m squared all of that cubed. We can write m squared all of that cubed as m squared times m squared times m squared. We add the powers and we get m to the power of 6. Part B. Simplify x to the power of 5 times x to the power of 8. Similarly to A, we add the powers and we get x to the power of 13. Part C. Expand 4p times brackets p squared plus 3p close brackets. Since we have to expand the brackets, the 4p will multiply both the p squared and the 3p. So 4p times p squared equals 4p cubed, and 4p times 3p equals 12p squared, making the expansion 3p cubed plus 12p squared. Question 2 for 5 marks. Johnny wants to know how much coffee he will need for 800 people at a meeting. Each person who drinks coffee will drink 2 cups of coffee. 10.6 grams of coffee is needed for each cup of coffee. Johnny assumes 68% of the people will drink coffee. Part A for 4 marks. Using this assumption, work out the amount of coffee that Johnny needs. First, let's work out the amount of people that will actually drink coffee. That will be 68% of the 800 people, and that is 544 people. We also know that each person will drink 2 cups of coffee, and that each cup will need 10.6 grams of coffee. Now, per person, we will need 21.2 grams of coffee. The total amount of coffee that he will need will be 544 times 21.2, giving us 11,533 grams to the nearest gram. Johnny's assumption is wrong. 72% of the people will drink coffee. Part B. How does this affect your answer to Part A? Since there's a higher percentage, that means that more people will need coffee, so that means that Johnny, will need more coffee. Question 3 for 3 marks. ACF and ADG are straight lines. BCD and EFG are parallel lines. Show that triangle ACD is isosceles. So the angle BCA is corresponding to the angle EFC, so that means it will be 125. Then angle ACD will be 55 because angles on a straight line add up to 180. Then angle ADC will be 70 again because angles on a straight line add up to 180. Lastly, angle CAD is 55 because angles in a triangle add up to 180. Now we have that 2 angles are the same in the triangle ACD, so that means it's isosceles. Question 4. It takes 14 hours for 5 identical pumps to fill a water tank. How many hours will it take for 4 of these pumps to fill another water tank of the same size? Since 5 pumps take 14 hours to fill the tank, 1 pump will take 70 hours. Now, if we were to use 4 of these pumps, then that will divide the time of 70 hours by 4, and then that will give us 17.5 hours. Question 5. A and B are numbers such that A equals 2 squared times 3 to the power of 4 times 7, and B equals 3 squared times 7 squared. Part A for 1 mark. Find the highest common factor of A and B. Since we'll need to find the highest common factor and the lowest common multiple, let's build a Venn diagram for the prime factors of A and B. We'll put 3, 3, and 7 into the intersection. We'll put 2, 2, 3, and 3 into the only A part, and the remaining 7 into the only B part. The highest common factor will be the intersection, so it will be 3 times 3 times 7, which equals 63. Part B for 2 marks. Find the lowest common multiple. The lowest common multiple is all of the numbers in the Venn diagram. So we'll do the only A part times the intersection times the only B part. Only A is 36, the intersection is 63, and the only B part is 7, making the lowest common multiple 15,876.
Question 6. Lava flows from a volcano at a constant rate of 11.9 meters cubed per second. How many days does it take for 67,205,600 meters cubed of lava to flow from the volcano? Give your answer correct to the nearest day. Flow rate is measured in meters cubed per second, which means flow rate is volume over time. So rearranging for time, we get that time is equal to volume over flow rate. The total time for 67,205,600 meters cubed to flow is 5,647,529.4 seconds. 1 second is 1/60th of a minute. So the time now in minutes is 94,125 minutes. 1 minute is 1/60th of an hour. So now the time in hours is 1568.7 hours. 1 hour is 1/24th of a day, so now the time in days is 65.4 days, which is 65 to the nearest day.
Question 7. Here is a graph of y equals x squared minus 2x minus 2. Part A for 1 mark. Write down the coordinates of the turning point of the graph of y equals x squared minus 2x minus 2. The turning point is the point in the curve where the curve changes direction. So our curve first started going down and then it started going up. And that changed happened at 1, minus 3. So that is our turning point. Part B for 1 mark. Write down an estimate for one of the roots of x squared minus 2x minus 2 equals 0. So the roots of a curve in this case are the points where the graph crosses the x-axis where y equals 0. Now in our case we have two, one at around minus 0.7 and the other one at around 2.7. Question 8. A solid cuboid is made of metal. The metal has a density of 9 grams per centimeter cubed. The volume of the cuboid is 72 centimeters cubed. Work out the mass of the cuboid. If you can't remember the formula for density, we can look at the units and figure it out that way. We can see that the units are grams per centimeter cubed. Grams is a unit of mass, and centimeter cubed is a unit of volume. So density is mass over volume. Now we can rearrange for mass, and we get the mass equals density times volume. The volume of the cuboid is 72 centimeters cubed, and the density is 9. So the mass is equal to 9 times 72, which is 648 grams.
Question 9. Some people were asked if they wanted a new television. 70% of the people said yes. 80% of the people who said yes wanted a television with a large screen. What percentage of the people asked said they wanted a television with a large screen? We want to know the number of people who said yes and want a large screen. 70% said yes, 80% want a large screen of the 70% people. The percentages become decimals and the and becomes times. So we get 0.7 times 0.8, which equals 0.56, which is 56%.
Question 10. ABD is a triangle. C is a point on BD. Work out the length of DC. We don't have enough information to work out DC directly. And as a note, it's important to know that line AC makes ACD and ACB right-angle triangles, which enables us to use sine, cos, and tan. So let's start by finding AC. We can use the sine rule as it is the opposite side to the angle 41, and we know the hypotenuse. So sine 41 will be equal to AC over the hypotenuse 6.8. AC works out to be 4.46. Now that we have AC, we can use the tan rule as AC is the opposite side of the angle 55 and DC is the adjacent side to the angle. So we get that tan 55 is equal to AC over DC. We rearrange for DC, which equals 4.46 over tan 55, which equals 3.1. Question 11. The table shows some information about the heights of a group of adults. Part A for 3 marks. On the grid, draw a box plot for the information in the table. To plot the information table, we can start drawing vertical lines at the least and greatest height, then at the lower quartile, followed by the median, and lastly at the upper quartile. Then we can draw horizontal lines uniting the least value to the lower quartile. We do the same for the upper quartile and the greatest height, and lastly we unite the quartiles into a box shape. Part B for 2 marks. Compare the distribution of the heights of the adults with the distribution of the heights of the teenagers. So the adults have a higher median height than the teenagers, but it also happens that the interquartile range is the same for both, and that means that they have the same spread of heights. Question 12. Show that x minus 1 times x plus 3 times x minus 5 can be written in the form ax cubed plus bx squared plus cx plus d, where a, b, c, and d are integers. We'll start expanding x minus 1 times x plus 3. X times x is x squared, x times plus 3 is 3x, minus 1 times x is minus x, and minus 1 times 3 is minus 3. We add the 3x minus x and we get 2x. Now we can expand x squared plus 2x minus 3 times x minus 5. x squared times x is x cubed, x squared times minus 5 is minus 5x squared, 2x times x is 2x squared, 2x times minus 5 is minus 10x, minus 3 times x is minus 3x, and minus 3 times minus 5 is positive 15. Now we can group the minus 5x squared plus 2x squared to minus 3x squared, and minus 10x minus 3x to minus 13x. So our final answer is x cubed minus 3x squared minus 13x plus 15. Question 13. An expression for the nth term of the sequence of triangular numbers is n times n plus 1 over 2. Prove that the sum of any two consecutive triangular numbers is a square number. A triangular number is given by n times n plus 1 over 2. The next consecutive triangular number will be given by n plus 1 times n plus 1 over 2, which simplifies to n plus 1 times n plus 2 over 2. We'll continue to expand the brackets. N times n plus 1 becomes n squared plus n. Then we expand n plus 1 times n plus 2 becomes n squared plus 2n plus n plus 2. Now we put it all together into a single fraction, regroup all the n squared terms, then all the n terms together, and we get 2n squared plus 4n plus 2 over 2. We simplify the 2, and it becomes n squared plus 2n plus 1, which factorizes to n plus 1 all of that squared, which is a square number. Question 14. OAB is a triangle. OBC is a sector of a circle with a center O. Calculate the area of OBC. Because we need to find out the radius of the sector, and we know two of the sides of the triangle ABO, and we also know the angle at A, we can use the cos rule to find the length OB. We get that the radius of squared is equal to 9 squared plus 6 squared minus 2 times 9 times 6 times cos 35. We put in the calculator, and we get that the radius squared is equal to 28.53, and then we solve for r, and we get that the radius is 5.34. Now that we have the radius of the section of the circle, we can work out that area. So generally, 360 degrees is the full circle, and we only need a portion of it. We need 80 degrees of it. So to work out the area, we work out 80 divided by 360 times pi times the radius 5.34 squared. Put in the calculator, and we get that the area is 19.9 centimeters squared. Question 15. For 1 mark, part A, factorize a squared minus b squared. Many will know this as the difference of two squares, and you can straight away know that it can factorize to a minus b times a plus b. But I will show you how you can arrive to this result. We add 0 as a common math trick, then 0 can become plus ab minus ab. We factorize the a from the first two terms, then we can factorize the b from the third and fourth term. And we end up with a times brackets a plus b minus b brackets a plus b. We do one last factorization of the a and the minus b, and we get a minus b times a plus b. For 2 marks, part B, show that 2 to the power of 40 minus 1 is a product of two consecutive odd numbers. 2 to the power of 40 is the same as 2 to the power of 20 times 2, which can be written as 2 to the power of 20 all of that squared. The 1 can always be written as 1 squared if you need it, and in this case we do need it. Now our problem looks a lot like the difference of two squares that we know how to factorize. So factorizing, we end up with 2 to the power of 20 minus 1 times 2 to the power of 20 plus 1. So 2 to the power of 20 will always be an even number, and when you add 1 or take away 1 to an even number, you always get an odd number. Since the difference between these two odd numbers is 2, they are consecutive. Question 16. On the grid, enlarge triangle T by scale factor -2 with center of enlargement -2, -2. The first thing we'll do is draw the center of enlargement at -2, -2. Then we'll align all three vertices of the shape to the center of enlargement. The green vertex moves 4 units to the right to reach the center of enlargement, so to reach the enlarged shape, it will move twice that. It will move away from the shape to the right because the scale factor is negative. The red vertex moves 3 units to the right and 3 units up to the center of enlargement. So to reach the enlarged shape, it will move twice that as well. Lastly, the blue vertex moves 5 units to the right and 3 units up to reach the center of enlargement. So to reach the enlarged shape, it will move twice that as well. Now we connect the dots and the vertices, and we have our enlarged shape with a scale factor of -2. Question 17. Here's a distance times graph. We have distance in the y-axis and we have time in the x-axis. Question A, for 3 marks. Find an estimate of the gradient of the graph at time 2.5 seconds. Firstly, we use the graph to find the point on the line where the time is 2.5 seconds. Then we draw a line that just touches the point and follows the general direction of the curve. We continue to find the furthest points on the line. In our line, our lowest point is 1.4 and 0, and our highest point is about 4.5 and 56. Then, the gradient is the change in y over the change in x. So we take away the y values from our highest and lowest points, and we do the same with our x values. We get that our gradient is 56 over 3.1, which is about 18. Part B, for 1 mark. What does the gradient of the graph represent? Our graph shows how distance changes over time, and we call that speed. Question 18. A solid frustum is made by removing a small cone from a large cone, as shown in the diagram. The slant height of the small cone is 6 centimeters. The slant height of the large cone is 10 centimeters. The radius of the base of the large cone is 3 centimeters. Calculate the total surface area of the frustum. The first thing we'll want to do is work out the radius of the top circle. We can fit 2 similar triangles to the cones to find it. The top radius over the base radius is the slant height of the small cone over the slant height of the large cone. Then we work out the radius to be 1.8. Then, to work out the curved surface area of the frustum, we'll need the curved surface area of the small and the big cone. And then we'll find the difference. The curved surface area of the large cone is pi times its radius 3 times its slant height of 10, which is 30 pi. The curved surface area of the small cone is pi times its radius 1.8 times its slant height of 6, which is 10.8 pi. The curved surface area of the frustum is the difference, which is 19.2 pi. Now we need the top and base surface areas, which are just 2 circles of radius 3 and 1.8. The top area is 3.24 pi and the base area is 9 pi. Now that we have all the areas, we can add them up and we get 31.44 pi. Lastly, to 3 significant figures, the total surface area of the frustum is 98.8. Question 19. Sana needs to draw the graph of y equals 3 to the power of x for x between 0 and 4. She draws the graph shown on the grid. Write down one thing Sana has done wrong. When checking if a graph has been drawn correctly, the main things that we want to check are the general shape of the line and where the line crosses the x and y axis. Let's have a look at where the line crosses the axis. So, according to the graph, it crosses through the origin at 0, 0. Now, let's check if that's true. We sub in 0 into the function, and we get y is equal to 3 to the power of 0, which means y is equal to 1. So the graph should cross the y-axis at 0, 1, not 0, 0. Question 20. Prove algebraically that 0.123 recurring can be written as 61 over 495. We'll start by setting 0.123 recurring to x, and then we'll multiply both sides by 10. We get 1.23 recurring equals to 10x. Then we'll multiply by 100 to get 123.23 recurring is equal to 1000x. We do this so we can align the recurring parts. We'll proceed to take away 10x from 1000x, and we get 990x is equal to 122. Now we've essentially removed the recurring part of the number. Lastly, we move the 990 to the side, we simplify, and we get that x is equal to 61 over 495. Question 21. Solve 1 over x plus 4 plus 3 over 2 minus 2x equals 1. Since we're adding fractions, the first thing we'll do is find the common denominator. We can multiply each fraction by 1, and for the first fraction, the 1 will become 2 minus 2x over 2 minus 2x. And for the second fraction, the 1 will become x plus 4 over x plus 4. Multiplying the first fraction, it becomes 2 minus 2x over x plus 4 times 2 minus 2x. Multiplying the second fraction, it becomes 3x plus 12 over x plus 4 times 2 minus 2x. Now that we have the same denominator, we can add the numerators, and we get x plus 14 over x plus 4 times 2 minus 2x equals 1. Since the fraction equals 1, that means that the numerator and denominator are equal. So we get x plus 14 is equal to x plus 4 times 2 minus 2x. We then expand the brackets, and we move all the terms to the left side, and we get 2x squared plus x plus 6x plus 14 minus 8 equals 0. We group the x terms together, and we also group the number terms together. Till lastly get 2x squared plus 7x plus 6 equals 0. Now, in order to factorize this, we'll multiply the 2 and the 6 to get 12. So now we think of two numbers that multiply to 12 and add up to 7. Those numbers are 3 and 4. So we split the 7x into 3x plus 4x. We can now factorize the first two terms. 2x squared plus 3x becomes x bracket 2x plus 3. And then we factorize the other two terms. 4x plus 6 factorizes to 2 brackets 2x plus 3. Now lastly, we do a third factorization of the x and the 2, and we get x plus 2 bracket times 2x plus 3 equals 0. Finally, we can treat the x plus 2 equals 0 and the 2x plus 3 equals 0 separately. So our first solution will have that x equals minus 2, and for our second solution, we get that x is equal to minus 3 over 2, or minus 1.5. Question 22. Given that the vector a26 plus b82 is parallel to the vector 13,6, find an expression for b in terms of a. Since the vectors are parallel, that will mean that the vector a26 plus b82 will be equal to some constant k times the vector 13,6. We can multiply the vectors, and the a26 will become the vector 2a, 6a, multiplying b times a2, that will become 8b, 2b, and the vector k 13,6 will become 13k, 6k. Now, the nice thing of a vector is that we can solve them separately. So, looking at the top row, we get that 2a plus 8b is equal to 13k. We make the k the subject of the formula, and we get that 2a plus 8b over 13 is equal to k. Now, we look at the bottom row, and we get that 6a plus 2b is equal to 6k. Making k the subject of the formula again, we get that k is also equals to 6a plus 2b, all of that over 6. Now we can equate the two results, and we can get a single equation that only contains a and b. Do cross multiplication, and we get that 12a plus 48b is equal to 78a plus 26b. We group the b's and a's together, and we get that 22b is equal to 66a. We move the 22 to the other side, and we simplify. Now we get that b is equal to 3a. Question 23. A circle has the equation x squared plus y squared equals 25. The point P with coordinates minus 3 and 4 lies on the circle. Alex says that the tangent to the circle at P crosses the x-axis at the point minus 8, 0. Is Alex correct? We'll start by working out the gradient of the perpendicular line to P, which is the line from P to the origin. The gradient is the change in y over the change in x, which is 4 minus 0 over minus 3 minus 0, which is 4 over minus 3. The gradient of the line tangent to P is the negative reciprocal to the tangent from P to the origin, because these two lines are perpendicular to each other, which means the gradient of the tangent at P is 3 over 4. Now that we have the equation of the tangent line as follows: y equals 3 over 4x plus c. To find c, we can sub in the value of x and y from point P. So we get that c is 25 over 4. Now we can check where the line crosses the x-axis and check if Alex is correct. The line crosses the x-axis when y equals 0, so we can sub in y into the equation, and we solve for x. Now, as we solve, we find that x is equal to minus 8.3 recurring, so Alex is not correct.
Question 24. There is a total of y counters in a box. There are x pink counters and 5 blue counters in the box. The rest of the counters are green. The ratio of x to y is 1 to 3. Freda takes at random 2 counters from the box. Find, in terms of x, an expression for the probability that Freda takes 2 counters of the same color. Give your answer as a fraction in the form ax squared plus bx plus c over dx squared plus ex, where a, b, c, d, and e are integers. We'll start by working out the probabilities, and then we'll work out the algebra. The number of pink counters is x, and the number of blue counters is 5. Since the ratio of the total counters to pink counters is 1 to 3, the total number of counters is 3x, which means that for the rest of the counters, for the green counters, it is 3x minus 5, which is 2x minus 5. Now, the probability that Freda takes 2 consecutive counters is the probability that she takes pink and pink, or a blue and a blue, or a green and a green. The probability that she takes a pink is x over 3x, and that she takes a second pink is x minus 1 over 3x minus 1. So the probability that she takes 2 consecutive pinks is x over 3x times x minus 1 over 3x minus 1. Now, the probability that she takes blue is 5 over 3x, and that if she takes a second blue is 5 minus 1 over 3x minus 1. So the probability that she takes 2 consecutive blues is 5 over 3x times 4 over 3x minus 1. The probability now that she takes a green is 2x minus 5 over 5x, and that she takes a second green is 2x minus 5 minus 1 over 3x minus 1. So the probability that she takes 2 consecutive greens is 2x minus 5 over 3x times 2x minus 6 over 3x minus 1. Now, or in probability means that we can add all of the probabilities. We now will work out the algebra. We expand the brackets on the numerators, and since they have the same denominator, we can just add the numerators. We put the x squares together and we get 5x squared. We put the x's together and we get minus 23x. And lastly, we add the numbers together and we get 50. The last thing we'll do is we'll expand the denominator and we get 9x squared minus 3x. So our final answer is 5x squared minus 23x plus 50 over 9x squared minus 3x.